This is an overview of PARSEC, a robotic prototype designed to extract and purify water from subsurface Martian ice.
Water is essential for life, food, industry, and rocket fuel, and there's currently a lack of refined technology for obtaining water on Mars. For humanity to have a sustainable presence on Mars, we need to develop a method for on-site water extraction, which would reduce the payload and make settlements possible. Recent discoveries from the Mars Reconnaissance Orbiter show large deposits of relatively pure ice near the Martian surface. Therefore, NASA created the Moon to Mars Ice and Prospecting Challenge, a competition to encourage student teams to develop robotic prototype systems to extract this ice. The primary goals of this competition were to collect the most water and to predict the overburden layers on a simulated Martian testbed.
To achieve these goals, we developed PARSEC, an all-in-one robot containing drilling, melting, extraction, and filtration tools on a novel rotary carousel frame. During operation, the system is mounted to a simulated Martian testbed, and the carousel is rotated to align the auger with the desired drilling position. The drilling system bores through the simulated surface until the machine learning algorithms indicate that the auger has reached ice. The drilling tool is then retracted and the carousel rotates to align the melting probe.
The melting probe rotates and articulates to reach a larger melt volume, and then the melted water is extracted by a peristaltic pump and directed to the filtration system. The water is then sent through a multi-stage filter and a reverse osmosis membrane to produce drinkable water. PARSEC uses two machine learning models for detection and classification of layers. One algorithm provides real-time detection of ice to inform when to switch from drilling to melting. The other algorithm uses data collected during drilling to identify the type of material at each position, and outputs them to our visualization tool for further analysis.
We had a successful performance of the system at competition. We were able to collect 16 liters of water, but were limited by a clog. Despite this clogging, we were able to double the previous competition record for water collection. Our main takeaways were that we need an extremely robust water transportation and filtration system, as we encountered clogs that limited our performance during both days of competition. Also, our training data was not similar enough to the competition conditions, which negatively affected the performance of PARSEC's machine learning algorithms. The final result was second place overall at the competition.
The next steps include making the system ready for harsh environmental conditions of space, mounting the system on a mobile rover base ready to navigate Mars, increasing the degree of autonomy which is necessary due to the communication delay with Mars, and finally, transitioning from a supervised to unsupervised machine learning model for post-drill layer classification.
Thank you for listening to our presentation. We are excited to be a part of the journey towards sustained human presence on Mars.